Hi everyone. I'm Seb. I'm a Kotlin Developer Advocate at JetBrains, and as I have been introduced so nicely, I'm here to talk to you about Compose for Desktop. Now, I want to settle expectations first of all. This is not going to be a tutorial because honestly, you can find those in written form, and you can sit down. You can actually follow along, which is probably going to be a more effective way of really diving into the technology. So instead, kind of the approach that I want to take is I want to provide you with a bit of a tastemaker. So give you a bit of background info, a general overview over the technology, show off some smaller examples, what I've built, what other people have built, and really give you the resources to kind of help yourself and to play around with this technology yourself. I also realized that you might be coming into Kotlin from different perspectives. I assume a lot of you folks are Android engineers. Some of you might be using Kotlin on the server side for some kind of backend development. In my wildest dreams, some of you are using Kotlin JS to build your front ends. If any one of you actually does that, please reach out. I still have hope. But yeah, I hope that you'll get something out of this talk either way. So let's just kind of try and motivate this whole story. So I'm a firm believer that the desktop is a really important platform, and having native applications that run on your local machine can be huge productivity boosts. But the problem is that building desktop user interfaces, and especially building cross-platform user interfaces, has been a bit of a problem for a longer while. In the JVM world specifically, we have JavaFX and Swing. As I have a bunch of colleagues who all work with Swing on an everyday basis because that's what we use for IntelliJ. They are not very big fans usually, so we're hopefully seeing some improvement in this regard. There's JavaFX, which, well, you get to write a bunch of XML and maybe hope that somehow you can install the visual forms designer, which has been unbundled at some point, and who really knows. And then of course there's other alternatives. There's things like Qt, or I'm sorry, I recently found out that it's actually pronounced Qt, which I think now has some very strange licensing per seat, per developer, kind of odd. Again, it's probably something you don't want to do if you're just building a small user interface. And then there's, of course, the classic, the current go-to, which is Electron, where you bundle a whole Chromium browser, and you've removed yourself from any kind of operating system standards. You're wasting a lot of memory, but you get a pretty good developer experience across multiple platforms, and you're still building desktop applications. So Compose for Desktop hopefully is the modern answer to the question of how can we efficiently develop beautiful user interfaces with Kotlin. And the exciting part about Compose for Desktop specifically, as the name might suggest, is that it is not yet another framework. But instead, it's kind of a flavor of the whole Jetpack Compose story, which Google has been driving. So while I want to talk about Compose for Desktop mostly, it's important that you understand what Jetpack Compose is. I assume that not all of you are working with Compose, so I'm going to try and help you understand that first. So let's look at the official website and try to figure out what Jetpack Compose is. So according to the official website, it's a modern toolkit for building native UIs. It has all these great buzzwords: less code, intuitive, it accelerates your development, and it's powerful. I don't know what exactly it means to be powerful, but I mean, hey, that's awesome. So what is it actually, though? Really, it's a declarative framework for building Android user interfaces, right? It's declarative in the same way like React, for example, is if you're coming from the web world, like Swift UI on iOS, or for example, like Elm. The basic concept behind all of this is just that you express your user interface as a function which is based on the current state. So instead of actively telling items in your application to move or to change, you always just change the state, and the system figures out intelligently how the UI should look after the change has been applied. Now, let's try to speedrun the world's fastest Jetpack Compose tutorial. I've just put a very small snippet on the screen so you can kind of, well, we have at least some code on the screen. In Compose, you essentially define two big things. The first thing is how you store your state. In this case, we just store a simple counter variable of type integer, and we have a bunch of fancy syntax around that. And we define what our user interface should look like. In this case, we say that we want to have a button that shows the content of the counter variable. And then if we click on this button, we have an on-click event registered, as you can see. And when someone presses the button, the counter just goes up by 1. And the magic of, declarative UI frameworks is that even though nowhere in this code we explicitly specify what should happen to the text label on our button when the state changes, Compose automatically figures this out and re-renders this change accordingly. Now, of course, it's also important to talk about the name-giving feature, which is, the fact that applications in Jetpack Compose are structured using composables. A composable is pretty much just a component that can be reused. They're classically organized in some kind of tree. And on this screen, you can now see, I believe, 3 composables, because we have the button, which is a composable. We have the text, and we can make our component, our weird counter, a composable too. So super rough thing. Generally, I want to kind of keep it light on code. We're going to have a bunch of materials for you in the end, just so that you get a general idea. Well, the big benefits of this is of Compose specifically is that it's a Kotlin framework. It's not some kind of adapter around a Java library or something else. So that means that it also makes full use of Kotlin's syntactic sugar, for example, or its type system. You're not going to end up writing an XML declaration of your user interface. Of course, if you're doing server-driven UI, you might be writing a GraphQL representation first and then kind of going from there. But generally, you can really write very nice and concise Kotlin, pure Kotlin code. And the beauty is also that being like a real Kotlin framework means that it also has all the ecosystem in mind. So there are, for example, if you're handling side effects, the launched effect function allows you to run suspend functions, which is inherently bound to Kotlin coroutines, for example. Or there's an extension function on Kotlin flows, which allow you to collect them as the state of your user interface. So it's really probably the most Kotlin way on how you can write user interfaces. And it comes with a bunch of other fun things as well, which make it a really powerful UI framework, even when we don't compare it with other things. So, for example, we have declarative animation UIs, which means you write a couple of lines of code, and again, it just kind of figures out what the animation should look like for you. It allows you to provide powerful and consistent theming across your whole application. You have access to the underlying primitives, like, for example, the canvas, if you want to do more fancy things or things that people didn't really intend to do. And it also comes with a large library of building blocks. On Android, those are just generally structured as material UI. And yeah, they just make it really easy to get up and going really quickly. So now I want to introduce you to Compose for Desktop. Compose for Desktop is exactly what its name implies. It allows you to write declarative user interfaces on the desktop. And in fact, this uses the exact same mechanisms as the Jetpack Compose library on Android. Now, this is extremely exciting for a number of reasons. First of all, it's of course, if you have worked with Jetpack Compose for Android before, you can just take that knowledge and you can just transfer it pretty much immediately to Compose for desktop. And if you haven't done anything with Jetpack Compose for Android before, you're kind of getting a 2-for-1 deal here, because if you learn Compose, you're going to be able to target those two platforms. So I think this is also really where a lot of the power of Compose for desktop comes from, because it takes the concepts that Google is pioneering and making really the new default for Android app development, and it allows you to reuse the exact same thing on the desktop. And as you can see here, it's a very subtle indication, but it actually comes with a library of material UI design elements, which means that if you just take Android Compose code, you put it on the web, it's almost just going to look exactly the same as you would run it on your mobile phone. And the great thing about all of this is that it's powered by a high-performance graphics library called Skia, which is built by Google. It's the same library that powers rendering engines for, or is the powering rendering engine for Google Chrome, for Flutter, and other like large projects that need to render a lot of user interfaces with high performance. As you can see, this we have support for the 3 large operating systems on desktop. We can run on Windows, Mac OS, and Linux. We're going to talk a little bit more about how we integrate with those platforms in just a little bit. Now, generally, pretty much all the Compose APIs that you can find on Android, you can also find on the desktop. So pretty much all of the features you can just transfer over. And honestly, this was how I first fell in love with Compose for desktop. The hype around Compose on Android has been growing really for a couple of months now. And I saw a bunch of examples from people who were building like cool animations and all kinds of weird and interesting UI paradigms. And when I first got my hands on an internal demo of Compose for desktop, I was able to literally just copy and paste the code from those Android examples, and they would just run on the desktop at 60 frames a second. And yeah, it just blew me away. So, of course, you don't just want to write the same stuff as you have on your mobile phone. So where it makes sense, Compose for desktop actually enhances the APIs for things that are specifically desktop related. So, for example, we have mouse events. If you want to make a text clickable, you can just do that by adding a clickable modifier. There's also other mouse events like on enter, on move. All of these things can be controlled, and you can interface with them directly. For other desktop-related stuff, we have, for example, support for images and icons, including vector graphics, SVGs, XMLs, and support rendering those directly to the native underlying canvas. We support keyboard events. We have desktop-specific scroll bars, which is nice when you're once again working with a mouse and keyboard. That's a bit of a different kind of way of interacting with things. And we also have system integrations, like putting up a tray icon, for example, or sending notifications through the native operating system's capabilities. Some of these things, like window APIs, for example, also don't really exist on Android, because you can't really just drag windows around. But we have this stuff in Compose for desktop. It just kind of builds on top of it. Now, currently, we're in the middle of milestone releases. So now is probably the most important time to give feedback for us. If you want to influence the way that these desktop-specific APIs are designed, I'll let you know. I'll point you to the place where you can report your issues at a later point. Now, if you are considering a user interface framework, you of course can't expect people to just throw away the existing applications they have. And just in the same way that Kotlin integrates with the Java user interface, the Java ecosystem, Compose for Desktop also interoperates with the Java UI ecosystem. So, for example, you can add a compose canvas to a Swing application. So you can have maybe one screen or even just a part of a screen of your application that you already built, legacy application maybe. You can just switch that out and build it in Compose for Desktop. And you can modify the state, as you can see, in both directions. And in fact, it's even possible to do it the other way around. So if you have some legacy components that were really hard to implement, you can have your Compose for Desktop application and add a Swing component right into the rest of your composition. It's not going to be quite as nice from the API, but hey, you don't have to redo all your work immediately. So usually people bring up the point of performance, which makes a lot of sense. As I said, Compose for Desktop is powered by the Skia graphics engine. That also means that we kind of get hardware acceleration support for all platforms quite nicely. So we have DirectX support on Windows. We have OpenGL currently on Linux and macOS, and we are looking into providing even a metal-based renderer on macOS in the future. So we are currently experimenting with bringing some of our production applications at JetBrains into using Compose for Desktop instead of using other frameworks. Now, this isn't like our flagship products or something. Don't worry, we're not going to immediately rewrite IntelliJ to just be Compose for Desktop. But we have applications which in their current state are taking about 600 megabytes, for example, of RAM. After moving them to Compose for Desktop, we managed to get them idling at about 60 megabytes, which is a big improvement over the Electron solution that we had beforehand. Good luck squishing a whole Chromium runtime into 60 megabytes. I want to see you do that. The other thing, of course, is if we are building native applications or if we are building desktop applications, we are in a bit of a different paradigm of how we ship this software. On mobile devices, we have app stores. You just package a thing as a central access point. On the different desktop platforms, we actually support different types of installers, which you can just generate with a Gradle task with a single click. Now, this is, again, very exciting because it means that you really have truly standalone packages, as in these are fully self-contained binaries that work on all kinds of systems, even systems that don't have a Java runtime environment locally installed. And for the outliers like macOS, where you're required to sign and notarize your application, we're also providing a lot of support for this. Now, let's kind of go a little bit of the other route and look at this from the perspective of an Android developer who already has built out their app experience on mobile. The beautiful thing is, again, this isn't some kind of adapter layer, or we're not trying to re-implement the same APIs or something like this. It's literally the same APIs, which means you can achieve essentially component level reuse. You design your application's UI components once, and you can run them on a mobile phone, like an Android device on the left, we can see here, or you can run them on the desktop, as we can see here on the right. And these would just be, for example, in a single multi-platform project, you reuse your UI, and Android Studio allows you to run both applications without any problems. So I personally believe that the best way to learn anything, honestly, including Compose for Desktop, means to build something. So I want to kind of, again, give you the tools on how you can build something yourself. So ever since IntelliJ IDEA 2020.3, we have a wizards integration for Jetpack Compose for Desktop, which means if you go to File, New Project, and you go to the Kotlin category, scroll all the way to the bottom, you'll see desktop and multi-platform application templates, which pretty much have everything pre-configured for you. So even if you're not a fan of writing Gradle configurations, for example, you can just get started. You'll have your first Hello World app up and running. Now, we actually bring a bunch of tutorials and related materials on the landing page for Jetpack Compose for Desktop, which you can find on jetbrains.com/lp/compose. We have some example code there, tutorials. There's also a link to the GitHub repository if you want to report issues, for example. You can check the changelog to keep up to date, all of these kind of things. But again, learning by doing, the easiest way, funnily enough, to get started with Compose for Desktop is to go through Compose for Android's pathway. Because so if you're not feeling like a certified Compose developer just yet, after I gave you a one-slide introduction, so you can really just go through this 10-step pathway, which covers pretty much all the basics. And the beauty is, once again, since they are the same APIs, you can just take you can re-implement the same things that the Google folks are demonstrating on Android. You can just build it on desktop, and it'll behave the same way. And it's quite nice because it combines articles, it combines some videos, and it also has code labs. So it really can help you understand. Now, over the last 4 weeks, Google also did a Jetpack Compose Android Dev Challenge. I think that's running out this week, so you might be a bit late to participate if you want to, but still to kind of give you an idea of what kind of user interfaces people are building with Compose in general, you can look for the hashtag Android Dev Challenge on Twitter, and then you can just imagine that instead of those things being phones, you can just imagine them as desktop user interfaces. That's the capabilities we have with Compose for Desktop. So there's a couple of ways on how to learn Compose besides just going through the introductory tutorial. We've already heard Compose Academy today, but since I kind of came from a web developer's perspective first, I really profited from Tiger Oaks's React to Jetpack Compose dictionary, because the good thing is that these days pretty much all platforms, they're declarative UIs. So we have Swift UI, we have React, and now we have Compose, and they pretty much all share the same concepts. So you just kind of need to learn the vocabulary, and you can really take it from there. If you want to dive into some more opinionated ideas of how we build Compose for Desktop applications and see some more complex demos as well, we have 4 or I believe 5 demo applications for Compose for Desktop specifically, which also all include information on how to share code between desktop and Android using multi-platform. So it's actually quite nice because they also all show different styles of architecture. For example, the to-do list example you can see all the way to the left here uses MVI Kotlin and Decomposed, which are both frameworks or libraries from Arkady Ivanov, who's been doing a lot in the Compose space. The image viewer and Jet issues show how you can do networking and serialization. And the code viewer, well, it's kind of a bit up our own alley, since we at JetBrains like writing code editors and viewers. One thing that I'm personally very excited about, and that maybe some of my colleagues are also excited about, is that we also have a demo of how you can build IntelliJ IDEA plugins using Compose for Desktop. So if you're interested in improving your own tooling workflows, for example, you can do that with Compose for Desktop as well. But really, again, there's not much I can do besides tell you to spend some time and build something yourself. When I first tried out the Compose for Desktop, I wanted to build a small companion application for building slide decks. So I quickly whipped up a small app that uses a REST API and just kind of provides me with a little search, a little copy paste feature. And within one afternoon, I had a completely working demo application that kind of, and again, this is something that very much convinced me just of the power of being able to rapidly prototype something and get something out the door. Unfortunately, I'm not a very good designer. So as you maybe have seen, that was very rudimentary. Some other folks have built much more impressive stuff using Compose for Desktop. Starting off a little bit more modest, but very nicely architected is John O'Reilly's People in Space app, which has Compose for Desktop. If you don't know John, definitely look him up. He's one of the most active folks in the Kotlin community, and definitely shines through his template and example repositories. So definitely give that a look. One thing that completely took me aback was Gurupreet's Compose Spotify desktop application, where he just re-implemented the whole Spotify user interface using Compose for Desktop. And I'm willing to bet that it has better performance than the current client, because I'm not very happy with that. There's also people demonstrating, for example, how they are designing their new note-taking apps using Compose for Desktop, again with fancy little animations, fade in, fade out, movement, all these kind of things. And then something came across my Twitter feed quite recently, which is the Apache 64's clock, which is an implementation of, apparently, I think it's called the kinetic clock, using animations to display time made up out of a lot of smaller clocks. So very much like this kind of stuff. Going kind of a little bit bigger, from the same gentleman actually is the application called Staxi. It's something that allows you to look at inside an APK file for Android and kind of figure out what kind of libraries are being used. So it's kind of a double way of learning here. Not only can you learn about how to build quite sweet looking desktop applications, you can also figure out what your favorite application on Android is using as their dependencies. So that's quite nice. And there's a lot of people in the Kotlin space kind of experimenting with this stuff, or building some smaller prototypes. So as I said beforehand, Arkady, who builds the MVI Kotlin library, is building a client for his applications using Compose for Desktop, which allows you to do time traveling. I'm very excited about this kind of stuff. We actually did a podcast with Arkady on the whole topic of how he does MVI Kotlin, what time traveling means in the context of model view intent and all these kind of things. So I'm just kind of shouting out our official YouTube channel here on youtube.com/Kotlin. And there's also PY who built some heap dump explorer based on Compose for Desktop, which once again, it's really awesome to see people not only adopt this technology, but kind of get up to speed very fast. So you can see that in this example, where there's not really a lot of fanciness going on, or a lot of this design going on when it comes to the user interface. But that just means that people were able to get something workable really quickly and just kind of get started. And I hope that if you try Compose for Desktop, you're going to have a similar experience. So the best way to engage with all of these people and many more is to join us on the Kotlin Lang Slack. We have the Compose for Desktop channel there, where a bunch of our team members are also hanging out, and are just kind of providing help, providing advice, and really trying to help you get started. Now, there's typically some questions I get regarding, well, we're doing code sharing, we're doing multi-platform, where is this stuff going next? So I don't have any official plans to share, unfortunately. But if you go to the JetBrains careers site, there's one UI framework developer position in the Jetpack Compose team to work on a web port of a certain cross-platform UI framework. So fingers crossed for that. And if you are very keen and you go through the Google source code editor, you can also see that Andrei Shikov at some point added some code for compiling Compose on Kotlin native. Maybe we can see something in the future there as well, maybe on iOS, who knows. This slide really just comes with my zero promises guarantee. Things may happen. The exploration space for Compose and Compose for desktop is really big. And yeah, I'm just excited to see where this is kind of going. I think it's a great way that demonstrates that there's still momentum behind this, that people are developing this, that it's just kind of a good time for everyone. So let's kind of wrap this whole thing up. What have we seen today? So when we think about Compose for desktop, we really get a nice way of doing cross-platform UI development using modern and declarative APIs. And if you compare it to some other cross-platform UI frameworks, you have the benefit of not only being able to reuse your code or your components, it's that you get to reuse any knowledge you might have from Android development, or vice versa. If you are doing Compose for desktop first, if you ever want to go mobile, it's going to be a breeze. So it's really a learn once, use for multiple targets type situation. All in all, I hope that I kind of showed at least a little bit how Compose can help you achieve delightful desktop development. So the next time you're considering to build a client for some kind of in-house application, or you're adding some functionality to an existing JVM desktop app, or you write a helper app that should try to increase your productivity, or, well, just extend your Android experience to the desktop, I would suggest considering Compose for desktop, because it really allows you to provide your users with a great experience, get the benefits of hardware accelerated, high performance user interfaces across all major desktop targets, and you still get to write Kotlin in all of this. So I think that's pretty neat. Yeah, so my call to action is go forth and compose some UIs. If you want to, you can stay in touch with me using any of the listed social media, I guess. I'm not sure if email counts as social media. I have a little bit of a bet going with a colleague how long it's going to take me to 1,500 followers. So if you want to give me a follow there, we'll be much obliged.